These are notes for section 9.6. Okay, 9.6, page 549, 1 to 77 odd. We're doing more work with complex numbers. As you can see, there's i's and square roots of negatives. Some more. Some more. And we have to go to 77, so a little bit more on the next page. Here we go. And the answer's in the back of the book. 9.6, here we are. Scroll over to the right a little bit. Here we are. Okay. All right, so 9.6, we're doing complex numbers. Once again, some of this should be review. So number one, square root of negative 36, take the negative outside, make it stand up as an I. I radical 36, square root of 36 is 6, so 6I. Okay, square root of negative 72, take out the negative, make it an I radical 72. 72 is 36 times 2, and so 6I radical 2. Okay, this is a note about powers of I. I to the first power is I. I squared by definition is negative 1. I cubed, well, you can pretend it's I squared times I. I squared being negative 1, so negative 1 times I or negative I. I to the fourth, you can think of it as I squared times I squared, which is negative 1 times another negative 1, or 1. And then it'll just cycle every 4. I to the fifth, pretend it's I to the fourth times I. And now we know I to the fourth is 1, so 1I or I. I to the sixth, I to the fourth times I squared. I to the fourth is 1. I squared is negative 1, so negative I. I to the seventh, you can think of it as I to the fourth times I cubed. Again, I to the fourth is 1. I cubed is negative I, so 1 times negative I, negative I. And I to the eighth, think of it as I to the fourth times I to the fourth, 1 times 1, which is 1. So we have a little table here of powers of I. I to the first, fifth, ninth, and 13th, and so on, equals I. I squared, 6th, 10th, 14th, and so on, that's negative 1. I cubed, I to the 7th, I to the 11th, I to the 15th, and so on, those are negative I. I to the 4th, 8th, 12th, 16th, and so on, those are equal to 1. Okay, now how about I to the 28th? That would fit this table, but you don't actually have to write it out. Instead, think of it as writing in multiples of 4. In other words, it's I to the fourth times 7. 4 times 7 is 28. And I know I to the fourth is 1. So 1 to the 7th, which is 1. I to the 26. Where does it fit here? Well, it's going to end up being on the second case, but it's easier to think of it again as powers of 4. So I to the fourth to the 6th, that's I to the 24th, leaving with another I squared. Okay, and I know I to the fourth is 1. So 1 to the 6th, which is 1, times I squared, and I squared by definition is negative 1. So I squared is negative 1. Okay, I to the 75th. Okay, it's almost really like taking 75 divided by 4 is 18, remainder 3. So I write it as I to the fourth to the 18th. 4 times 18 is 72, and then I cubed. So here's 1, 1 to the 18th, I cubed. So 1 to anything is 1. I cubed is equal to negative I. So the final answer is negative I. 15, 2x plus 3yi equals 6 minus 3i. I just equate the real part. The real has to equal the real. 2x has to equal 6. The imaginary has to match the imaginary. 3yi equals negative 3i. So that means 3y has to equal negative 3. So that means x is equal to 3 and y is equal to negative 1. 19, same thing. 2x plus 10i, negative 16 minus 2yi. The real part has to match 2x minus 16. The imaginary part has to match. 10 has to equal negative 2y. So that gives me x is negative 8 divided by 2. Y equals negative 5 divided by negative 2. Okay, 23, 7x minus 1 plus 4i equals 2 plus 5y plus 2. So all the real parts have to match and the imaginary parts have to match. Okay, so this and this have to match. 7x minus 1 has to equal 2. And this 4 has to match 5y plus 2. Okay, so add 1, divide 7, x is 3/7. Here, subtract 2, divide 5, y equals 2/5. Okay, 41. This is pretty much just distributive property. Multiply it out, except anytime you see an I squared, change it to -1. So distribute, that times that is 12i. 3i times 5i is 15i squared, but you never leave an answer as I squared or I cubed or anything like that. We can always break it down further by using these rules. So the thing that happens a lot is I squared. Every time you see an I squared, it's -1. So write it in a plus bi form. That means the real part always comes first. So -15 plus 12i. Okay, this one is just FOIL, except anytime you see an I squared, change it to -1. So first, 12. Outer, -4i. Inner, plus 27i. Last, -9i squared. And there's the I squared. I squared becomes -1. So leave that alone, leave it alone, leave it alone. But it's -9 times -1, which is 9. Okay, and then 12 plus 9 is 21. -4i plus 27i is a 23i. 53, square this. So use the formula for squaring. A squared plus 2ab plus b squared. So my a squared is 4. 2ab, 2 times 2 times 5i is 20i. Plus b squared, 5i squared is 25i squared. But again, I squared changes to -1. So 25 times -1 is -25. And 4 minus 25 is -21. So final answer, -21 plus 20i. 63, we're multiplying conjugates. That's like a plus b, a minus b. So I don't have to do FOIL. It's not first, outer, inner, last. It's just first and last. So first, 2 times 2 is 4. Last is -9i squared, but that I squared is -1. So it's -9 times -1, 4 plus 9, final answer of 13. 67, rationalize the denominator, 2 minus 3i divided by i. Just multiply top and bottom by I. That way you get an I squared in the bottom, which is just -1. Okay, and the numerator is 2i minus 3i squared. Change I squared to -1, so 2i minus 3 times -1. So 2i plus 3, and then distribute the -1, put the real part first, -3 minus 2i. Okay, 71, you multiply by the conjugate of the denominator, 2 minus 3i, 2 plus 3i, top and bottom. So the bottom is 2 times 2 is 4, minus 9i squared. Again, that's -9 times -1. It's going to become 4 plus 9. The top is 4 times 2 is 8, plus 12i. So 8 plus 12i divided by 13, split it into 2. So final answer, 8/13 plus 12/13 I. Okay, finally 77, similar theme. 5 plus 4i over 3 plus 6i, multiplied by the conjugate of the denominator, which is 3 minus 6i over 3 minus 6i. If this had been a minus, we multiply by the positive. So the denominator is just 3 times 3 is 9, minus 36i squared. That's minus 36 times -1. That becomes 9 plus 36. So you have a nice denominator. Top is FOIL. 5 times 3 is 15. 5 times a -6i is -30i, plus 12i is -18i, minus 24i squared. There's that I squared again, change it to -1. So that becomes a plus 24. 15 minus 18i plus 24. 39 minus 18i divided by 45. Break it into 2 and reduce. This reduces to 13 over 15 minus, take out a 9 here, 2/5 I. Okay, and that is section 9.6.